Okay, 7.1 notes is on special triangles and trigonometric ratios on page 3 in your notes. So today we are going to memorize the pattern in 45 degree, 45 degree, 90 degree, and 30 degree, 60 degree, 90 degree triangles. We're also going to find the 6 trigonometric ratios of parts of right triangles. So lots to do. So in a 45, 45, 90 triangle, notice that the angles add up to 180 degrees. And notice that these two angles are the same measure. That means the sides opposite those angles will be the same. So whatever number length this leg is, this leg will be the same thing. Notice this is the long side. It's called the hypotenuse because it's opposite the 90 degrees. And then for this length, you would take the leg number and multiply it by the square root of 2. So for example, in this picture here, we have a 45, 45, 90. If this leg is 8, then this leg is also 8, and then the hypotenuse is that number times the square root of 2. So it would be 8 square root 2. If we're given the hypotenuse is 6 square root 2, then that means that the legs are both 6 to make that pattern hold. This was a little bit tricky though because the hypotenuse does not have the square root of 2. So in this case, we're going to divide by the square root of 2 to find the legs. And there is a trick for doing this. So if you're going to, if the square root of 2 is not in the hypotenuse, then it's going to be in both legs. And then you take the number and divide by the number in the root. So 8 divided by 2 is 4. So that means both legs are 4 square root 2. So to do some examples, notice this angle has to be 45 degrees to add to 180. If this leg is 6, this leg is 6, making the hypotenuse 6 square root 2. You'll notice during the lesson I'm leaving some blank for you to try. So skipping to this one, if this angle is 45 and 90, this has to be 45 to add to 180. The hypotenuse is 9 square root 2, making both legs 9. This is a try. For this one, if this is 45 and 90, this angle has to be 45 to add to 180. Notice this is the hypotenuse since it's opposite the 90 degrees, so the legs are both 5 and 5. Try that one on your own. These are harder. Notice the missing angle is 45. This should have a square root of 2, but it does not. That means the square root of 2 is in both legs. And then you divide this number by the number inside the root. So 6 divided by 2 is 3, making both legs 3 square root 2. In this one, 45 degree angle. Again, this is where the square root of 2 should be. If it's not where it should be, it's going to be in the other two sides. Divide this number by the number in the root. So 12 divided by 2 is 6, making both of these legs 6 square root 2. New pattern. This is a 30, 60, 90. So notice the legs will not be equal because the two angles are not equal. But notice all three angles add to 180 degrees. Since this is the smallest angle, the side opposite that will be the smallest side. So this is going to be the smallest number. Opposite the 60 degrees, you would multiply that small number by the square root of 3. And then to find the hypotenuse, the longest side, because that's the biggest angle, that should be the biggest side, you take your small side number and you multiply by 2. So it's always double the small side for the hypotenuse. So in this picture, notice we're given the small side is 6. So to find opposite the 60, you would multiply that by the square root of 3. So this is 6 square root 3. And then opposite the 90, you multiply by 2. So 6 times 2 is 12. Notice the hypotenuse is double the small side. In this example, you're given the hypotenuse is 6. So to find the small side, you have to take half that. So half of 6 is 3. So opposite the 30 is 3. Then to find opposite the 60, you take your small side and multiply by the square root of 3. So it's 3 square root 3. Notice this one, opposite the 60, that's where the square root of 3 should be. When it's not where it should be, the square root of 3 is going to be on the other two sides. So then you take this number and divide by the number inside the root. So it's 6 divided by 3, which is 2. So that'll be your small side. But for your big side, you have to double it. So that will make 4 square root 3. So some examples. Notice this is 30 and 90. That makes this angle 60. We're given the small side is 5. So opposite the 60 would be 5 square root 3. And then to find the hypotenuse, you double the small side, so 5 times 2 makes 10. Try this on your own. Over here, the hidden angle is 60. Notice you're given the small side is 8, so that means opposite the 60 is 8 root 3. And then the hypotenuse is double, so 16. Try this on your own. For this one, you're given 30 and 90. That makes this angle 60. And we're given the hypotenuse, which is the long side. So we have to find the small side. So we're going to take half of the big side, which is 10, and that should go opposite the small angle. So this side is 10. Then to find opposite the 60, you would multiply by the square root of 3. Try this on your own. For this one, the missing angle is 60. Notice this is where the square root of 3 should be, and it's not there. That means the square root of 3 is in the other two legs. You divide this number by the number inside the root. So 6 divided by 3 is 2. So our small leg is 2 root 3. And then to find the hypotenuse opposite the 90, you double that, so it becomes 4 root 3. During this one, this angle has to be 30 to add to 180. Notice this should have the square root of 3 and it does not, which means it's in the other two sides. You divide the 9 by the number inside the root, so 9 divided by 3 is 3. And then you double it to find the hypotenuse, making that 6 square root 3. All right, so now to do trigonometry. This angle is called theta. Notice that this is the hypotenuse because it's opposite the 90 degrees. It's the largest side in the triangle. And then if this is theta, the opposite of that angle is over here. And then the adjacent side, the side that touches the angle but is not the hypotenuse, is called adjacent. So then our sine ratio is written the sine of theta equals the opposite over the hypotenuse. The cosine ratio is written cosine theta equals adjacent over hypotenuse. And then the tangent ratio is written as the tan of theta equals the opposite over adjacent. Some of you might remember the phrase SOHCAHTOA in order to remember these ratios. There's also a highly inappropriate sentence to help you memorize how to spell SOHCAHTOA. That would be some old hippie caught another hippie tripping on acid. Inappropriate, but it does help you remember how to spell SOHCAHTOA. Then we're going to talk about the reciprocal trig ratios. So cosecant is the reciprocal of sine. Cosecant is shortened as CSC of theta. And then you flip the fraction, so it's going to be hypotenuse over opposite. Secant is shortened as SEC of theta. And then when we flip the fraction, it's H over A. Cotangent is reciprocal of tangent. It's shortened as COT of theta. And then flip the fraction, it becomes A over O. So if you want a phrase like SOHCAHTOA, this could be cho, sha, cow. I'm sorry, I have no inappropriate sentence for cho, sha, cow. Couple things to note. Notice that the way it should be, the reciprocal of sine, I would have it start with the letter S, but notice it starts with the letter C. Whereas the reciprocal of cosine, I'd have it start with the letter C, but instead it starts with the letter S. So notice that these are backwards from each other. So you have to keep that memorized. The other thing to note is there are two C's in the reciprocals when you do cho, sha, cow. So be ready for that one. So our first example, we have a triangle. Notice this is not a 45, 45, 90 because that would make this 3 root 2. And notice it's not a 30, 60, 90 because double the small side, that should be a 6, not a 5. So if we're trying to find the missing leg, you have to do the Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. My legs are x and 3, so it's x squared plus 3 squared equals the hypotenuse squared, which is 5 squared. So we're going to simplify. We have to leave x squared alone. 3 squared is 9 equals 5 squared is 25. We have to minus the 9 over, so we get x squared equals 16. Square root both sides, you're going to get plus or minus 4, but the leg can't be negative, so it's just 4. So let's go ahead and put that in the picture. Since we have theta, we can label the sides. So notice this is the hypotenuse in our triangle because it's opposite the 90. This is adjacent. It's touching the angle, but it's not the hypotenuse. And then the 3 is opposite theta. So our sine ratio is so, O over H, so 3 over 5. Cosine is ka, A over H, so 4 over 5. Tangent is toa, O over A, so 3 over 4. Cosecant theta is a reciprocal of sine, so we can just flip this, and it's 5 over 3. Secant is a reciprocal of cosine, so 5 over 4. And cotangent is the reciprocal of tangent, so it's 4 over 3. Okay, so notice this triangle is not a 45, 45, 90 or a 30, 60, 90 because it doesn't follow the pattern. So we have to do the Pythagorean theorem. So the formula is leg squared plus leg squared equals hypotenuse squared. Notice our legs are x and 4 with a hypotenuse of 6. So that would give us x squared plus 4 squared equals 6 squared. To simplify, we get x squared plus 4 squared is 16 equals 6 squared is 36. You have to minus the 16 over, so you get x squared equals 20. We're going to square root both sides, but that means you have to factor tree the 20. So you're going to have 5 times 4, and 4 makes 2 times 2. You have a pair of 2s, so the 2 comes out, and the 5 is stuck inside. So our missing leg is 2 square root 5. Now we can label the triangle. Notice the hypotenuse opposite the 90 is 6. Notice theta is up here. That means the adjacent side is over here. And then opposite theta is 2 root 5. So for the sine ratio, sine is so, O over H. I'm going to get 2 square root 5 over 6. Notice you can reduce this fraction. The numbers on the outside can reduce. So 2 goes into 6 3 times, giving me the square root of 5 over 3. Cosine is ka, A over H, so that gives me 4 over 6. I can reduce that to 2/3. Tangent is toa, O over A, so I'm going to get 2 square root of 5 over 4. Notice I can reduce that fraction. 2 goes into 4 twice, so it's the square root of 5 over 2. Now for the reciprocals. Cosecant is a reciprocal of sine, so I'm going to go to the reduced fraction and I'm going to flip it, so it's going to become 3 over the square root of 5. However, you can't leave the square root in the denominator of a fraction, so we're going to have to rationalize. There is a trick to rationalize. You leave the number on top, so the 3 is staying there. Then you move the square root of 5 to be on top as well, so that's going to be 3 square root 5 on top. And then it's the number on the bottom without the square root. That will be your final answer. So the number on top stays on top, the square root moves up, and then the number comes out of the square root on the bottom. For secant, it's a reciprocal of cosine, so we just flip this. That becomes... Okay, cotangent is the reciprocal of tangent. So we're going to flip the simplified one, so it's 2 over the square root of 5. Notice that needs to be rationalized, so the number on top stays on top, the square root of 5 moves on top, and then the number comes out of the root on the bottom. So it's 2 square root 5 over 5. Number 2, if we're given a point, find the 6 trigonometric ratios. So we're going to make a sketch of this. So if our point is negative 5, 12, starting at 0, 0, you're going to go left 5 and up 12. It's going to make a point here. Then you would have to draw this triangle in a very specific manner. So that you're going to draw the triangle to connect to the origin. That's always the hypotenuse. And then you connect it to the x-axis, creating a right angle here. So now we have a right triangle. Since you're going left 5, that leg is negative 5. And then you're going up 12, making this leg positive 12. Notice we don't know the hypotenuse. So this is where we would do the Pythagorean theorem. So it's leg squared plus leg squared equals hypotenuse squared. My legs are negative 5 and 12. So negative 5 squared plus 12 squared equals the hypotenuse squared. That's what we're solving for this time. So when you square negative 5, it becomes positive 25 plus 144 equals x squared. When you add that, you're going to get 169. You have to square both sides, you're going to get 13. So the hypotenuse is 13. Your theta, the angle inside this triangle, is always at the origin, so it's down here on the bottom right. So we want to label the O, the H, and the A. So in this case, this is the hypotenuse. This is adjacent to the angle at the origin, and 12 is opposite the angle at the origin. So we're going to find the sine ratio. Sine is so, O over H, so you're going to get 12 over 13. And notice that does not reduce. Cosine is cut, A over H. So in this case, it's negative 5 over 13. And don't be confused by the negative. The negative is to show the direction. Whenever you go left or down, it's negative. The tangent ratio is TOA, O over A, so that'd be 12 over negative 5. For the reciprocals, cosecant is the reciprocal of sine, so it's 13 over 12. Secant is the reciprocal of cosine, so it's 13 over negative 5. And cotangent is the reciprocal of tangent, so it's negative 5 over 12. Go ahead and try B on your own. Notice you're going to go right to down 5. So that down side is going to be the negative this time. For this problem, you're given the cosine ratio is 3 over 4, and we are supposed to find the remaining 5 ratios. So to see what we're talking about, let's draw a right triangle. I'm going to pick the bottom left angle to be our theta, and then I'm going to label the triangle. So this is the hypotenuse in my right triangle. This is adjacent to that angle, and this side is opposite of that angle. So we're given that cosine is 3 over 4. Remember, cosine is ka, A over H. So they're telling us the adjacent is 3, and our hypotenuse is 4. Notice we're missing the opposite side. So we have to do the Pythagorean theorem. So it's leg squared plus leg squared equals hypotenuse squared. So x squared plus 3 squared equals 4 squared. This simplifies to be x squared plus 9 equals 16. Minus the 9, you get x squared equals 7. Square both sides, you get the square root of 7. That's our missing opposite side. So now we can find the remaining ratios. So the sine ratio is so, O over H. So this is the square root of 7 over 4. Cosine is ka, A over H. That gives me 3 over 4. Tangent is TOA, O over A, so it's the square root of 7 over 3. And notice it's okay to have the square root on top, it's just not on the bottom. So that's why these are okay. For cosecant, you're going to flip this fraction, so it's going to become 4 over the square root of 7. It's not okay to have the square root in the denominator, so we have to rationalize. So the 4 stays on top, and the square root of 7 moves up, over the number comes out of the root on the bottom. So it's 4 square root 7 over 7. Secant's the reciprocal of cosine. You flip this, you get 4 over 3. And then cotangent's the reciprocal of tangent. We're going to flip this and get 3 over the square root of 7. You need to rationalize. The 3 stays on top. The square root of 7 moves up over the whole number 7 on the bottom. Go ahead and try B. Keep in mind this is the square root of 3 over 1, so be careful of that. I'm going to skip all of number 4. So go ahead and finish all the try me problems if you haven't already, and then ask the substitute for your homework.